And we're live. Let's tweet out. Share with Twitter. Share with Slack. Let's see, devs, not general. Topic Twitch. Perfect. Okay, and we got our chat room up here. I forgot my glasses at work, I think, or upstairs or someplace. Basically, I couldn't find them this morning right away, but I'm sure I'm going to find them shortly today, hopefully. It is a Tuesday morning, which these are tough for me to wake up right now, and I'm hoping that they'll get a little bit easier for me, especially with like the move and get anything else up. Sort of throws the sleep schedule into a whack, but it's also something that I want to like continue to do because this is really good for both my skills in doing this, and I'm hoping it's also useful to other people who are learning Rust as well. So what I was planning on doing today was just sort of looking through the departments and grabbing anything. Like we did this derive debug yesterday. Is there anything other like gotchas? And then throwing them in a wiki, and then moving on to chapter 9. So I think another one, and this is like a pretty good enum right here, because it shows, you have just the enum with just a pure type with no data attached to it, and enum with a this is an enum with a what is it called? Anonymous struct, and then an enum with just a single type. Like this one too. That didn't sound good. That was my keyboard tray settling it in place. Okay, so if I save this, move over to here, we got printing values, enums. I just probably want enums. Which then means over here we just create a file named enums.md. Oh man, I just had your actual name in my mind, and I totally forgot what it was. I wanted to say like Marcus, but I think that's wrong, right? Is it Miguel? Is it? Let me know if I'm right. But either way, welcome. Good morning. Glad to have you here. Hello. Okay, so with enums, we just paste in this. This is rest do, and we could even have this is an example of enum takes in an anonymous. Oh god, that's horribly misspelled. Anonymous data structure. Just a pure value, a new type. It's Miguel. So I eventually got it. Let's see, a new type and a type with a string value. So I think documentation, the actual maybe documentation where we can find this. I believe that when I was looking for this and I was pointed towards the sort of like example. So is that this? No, that's the full documentation. I think it's enums enum rust. If I just do that, enum values, those are strings taken in, back tuples. Okay, so they have all this stuff. So this is what we want. I think that's pretty simple going through for that. We need. So what I heard is that in the new 1.26, we can use this question mark inside of main, but only if it returns an IO result, which means we also need this thing at the bottom. But that allows us to use this question mark, which essentially says, hey, if this has an error, just panic. Like no other code needed. So that's a fun one too. We go back to home. I think it was like an exceptions. So rest except yeah, rest exception, because it returns this result and we want to match this thing. Does it have the question mark operator in here? That's the debug. 13 matches. Or propagate the error up the call stack with the question mark operator. So yeah, we have, okay, so write message, IO result, then this thing. So what we really want is error handling. Error handling, new file, error handling.md. And so basically the general idea is many ways to handle errors. Now the thing that I care the most about right now is using that question mark operator. So so I think first of all, we have our documentation, which is not there, it is here. But once we have that, then it's like, okay, using the question mark operator to handle errors in the main function, so we don't have to write a match statement just to panic code. Okay, so that will be this entire thing, except I'm going to replace the function with main. This is going to be main. We have to return this IO result. Let mute. So I think turn. What? No, not right now. Return statement is necessary. Also, this is what we are returning. It allows the question mark to be used. I don't know if there's anything else necessarily to do in here. Like it's clear, like, okay, this is what we're doing, and this question mark is if there's an error, panic. So question mark means if there is an error panic. Okay, so I think that's good there. Know how to do these. The infinite loop is nice, but we've got that down. This was fun to write, but I think we're going good with this. Match command parts. These are good. We have our commands. Was there anything crazy in here? So I mean, this is just so using the enum, but I think that was fine. No, so one thing I am realizing is that I am very much relying upon strings in the well, our big capital strings. Where are they going? They're in the stack or the heap. The strings in the heap a lot more than probably I should, but I think that's because of like ownership and passing them around. So it is like creating and deleting way more memory than I necessarily need to. And I think part of that is just it's going to take me a little bit of time to understand other alternate ways of doing stuff as opposed to sort of doing the current style that I know and sort of like putting that in Rust. But that's just experience, I think. And putting my code out there so that other Rust people can constantly remind me how I can do it better. Okay, command, add this. So the entry or insert, these are pretty cool. So this allows us, yeah, so this stuff allows us to say, okay, we're gonna run this off of department's hash. We have this entry, or we're going to insert. But then this is a mutable reference, but we don't even have to mention it as a reference. It's just automatically given to us that we can now use. I also realized that this was indented incorrectly. So I like this thing where I can do the entry or insert. So I think that is back to home. We're gonna add in hash maps. You know, one nice thing about this this wiki format, especially on GitHub here, is that it's a free wiki. I mean, that's always a nice thing, you know, to have it for free and still be a high quality wiki. But it's also that I currently was able to set it so anybody that has a GitHub account can make updates. And of course, it's still GitHub. So if somebody makes an update that doesn't improve things, we can still see what the previous things were. But for right now, like if the community, if you guys do want to update this, play around with it, please feel free to go in. I have it's the wiki attached to the Learning Rust repo, which I do have linked both in the Twitch sort of channel description and the YouTube descriptions when I upload these. Okay, so for hashmap, we want specifically this thing. So what are we doing here? This is really just going to be methods that we are useful. So in this case, this is the entry or insert. or maybe like, so first is entry, which is entry is used to get a mutable reference to an item, a value, a value in the hash map. It returns as an option sum, option none. I'm only writing that out there in that way, so that way my like a grep could work with it. So there's that. We have the documentation for it. Which now let's go find. So we'll do it right here. We have a Rust hash map, and we want a entry. Okay, so implements entry, but then we have these other like or insert. Okay, so I want to go to entry here. Yeah, okay, so this one gets a given key's corresponding entry in the map for in-place manipulation. That's what we want right here. So tab this in, let mut d equals department's entry. And I could do this. Data push equals name. Okay, that's fine. And then of course we have dot or insert, which is or insert is used to to insert new data into the hash map in the case that the entry used previously didn't find any data. It will be what is returned if there was no original key. So for this, we'll do documentation. Now, I believe we had just been here to the or insert right here. We kind of want to do, okay, so we have this dot entry, but then we could also do the dot or insert and then put in something like a new anonymous vector that's empty. All right, so I think that's good too. Let's see, iterating through, I think those are fine. Get by department. And then we already have that. Okay, so I think we're good here. I can come back, add all these things, which is updated wiki from the department challenge. And sending that on up. So I'll just keep this running in the background. This was, what did I do different here? I'm not actually seeing what I did different, changes wise. Isn't it supposed to, like, these are all looking exactly the same. But regardless, I'll send this on up. Hopefully it's still good. Noticed that it saved. And we'll send that on up too. And that means it's time for a good 20 or so minutes of chapter 9. We'll see how we go there. Let's close you. Gonna open up oh, I wanted to go into mine learning Rust just on its own. Then we're gonna take chapter 9. Wait. I don't know why that kept it in my buffer there, so I don't need this chapter 9 inside of it because I'm already in a chapter 9 here. So let's go ahead. We're gonna work out of here. Let's go back to Firefox. We're gonna Rust book. The second edition. Come down, find chapter 9. Close that. All right, everything should be looking good. Error handling. Rust's commitment to reliability extends to error handling. Errors are a fact of life in software. So Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This requirement makes your program more robust by ensuring that you'll discover errors and handle them appropriately before you've deployed your code to production. I have actually seen code in the wild where there was sort of like the equivalent. It was a C#, but it was the equivalent of like responding to a server request with like, yep, this this something messed up. This is an error. Like that was the string that was sent. Clearly they had meant to go back and change things and had either forgotten to or left the company before they did. So that was fun. And it sounds like this actually prevents that because they wouldn't be able to compile it even to test it without an actual error being there. Rust groups errors into two major categories, recoverable and unrecoverable errors. For a recoverable error, such as file not found error, it is reasonable to report the problem to the user and retry the operation. Unrecoverable errors are always symptoms of bugs, like trying to access a location beyond the end of an array, right? Out of bounds error. Most languages don't distinguish between these two kinds of errors and handle it both in the same way, using mechanisms such as exceptions. Rust doesn't have exceptions. Instead, it has the type result for recoverable errors and a panic macro that stops execution when the program encounters an unrecoverable error. This chapter covers calling panic first, and then talks about returning result values. Additionally, we'll explore considerations when deciding whether to try to recover from an error or to stop execution. Stacking. Good morning, welcome to the stream. Black Ops 3 had a major bug and the error message was just A-Z. That, I wish I could say that more major applications don't have silly things like that, but it's always sort of fun to see those in the wild and see where developers just felt rushed. And because the language allowed them to do it, that's what they did. And I think that's something I'm liking about Rust, is because it's going to be a built-in, like if you want it to happen, don't allow it not to happen. something that I'm learning more and more as time goes on. Okay, so let's move on. Unrecoverable errors with panic. Sometimes bad things happen in your code, and there's nothing you can do about it. In these cases, Rust has the panic macro. When the panic macro executes, your program will print a failure message, unwind, clean up the stack, and then quit. This most commonly occurs when a bug of some kind has been detected and it's not clear to the programmer how to handle the error. Unwinding a stack or aborting in response to a panic. By default, when a panic occurs, the program starts unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. But this walking back and cleanup is a lot of work. The alternative is to immediately abort, which ends the program without cleaning up. Memory that the program was using will then need to be cleaned up by the operating system. If in your project you need to make the resulting binary as small as possible, you can switch from unwinding to aborting upon a panic by adding panic equals abort to the appropriate profile sections in your cargo.toml file. For example, if you want to abort on panic in release mode, add this. So that's interesting. So I guess the question is like, do we want the operating system to do the cleanup of the memory, or do we want the program to? If the program cleanups the memory, it's really just making system calls to the kernel to release it, saying like, hey, we're deallocating all this. I kind of personally prefer that, but I think the reason is because like when I was a systems administrator, I often ran into problems where programs had sort of crashed or released the memory, but the operating system wasn't able to, for one reason or another, to release that memory up. Then it just became, it just sat there as sort of corrupted memory, and had a reboot was the only way to recover. I don't see why you wouldn't want the OS to clean up memory as long as the program crash saved. Well, the OS is still doing the one recovering the memory, but it's just, do we want the application to do the best attempt to tell the operating system to recover the memory, or do we want sort of like, it's still basically signed saying I own this memory, but then the application isn't running anymore. So the OS has to notice and say, oh, okay, you don't exist. Like the process doesn't exist. The links to the memory are no longer valid. Okay, let me find and clean up all this memory. So like personally, I feel that like an attempt to be a good citizen to the operating system is a good thing, but that may be like my side from the system side is like, I don't know how much I trust that'll work super well with every operating system. Will it create a zombie? I don't know. That would actually be even worse. Let's try calling panic in the simple program. Okay, so we're gonna create a main program with just panic, crash, and burn. Let's go do that. So we're gonna create cargo, panic, cargo create, cargo new panic. And we're going to code, I guess I need to go into panic. We'll code here. So in our source, instead of like print line, we can just do panic, and it is a macro, so we have that exclamation mark. If we run this, I understand we have update for you. Now we can do cargo run. Thread main panicked at hello world. Okay, so it just puts this message saying like this is where it panicked at, but it is nice. It still is able to give us the sort of trace. Run with backtrace for a full backtrace. Okay. The call to panic causes an error message containing the last 3 lines, which is these. The first line shows our panic message. Oh yeah, okay. The first line shows our panic message. There it is. And the place in our source code where the panic occurred. Source main rs24, which is right, it's the only line we had, indicates that it's the second line, 4th character of our source main rs file. In this case, the line indicated is part of our code, and if we go to that line, we see that panic macro call. In other cases, the panic call might be in code that are code calls, and the file name and line number reported by the error message will be someone else's code where the panic macro is called, not the line of code that eventually led to the panic call. We can use the backtrace of the functions the panic call came from to figure out the part of our code that is causing the problem. We'll discuss what a backtrace is in more detail next. Does abort also create a backtrace? So I think for this one, it's immediately, or I guess this is not immediately. This is crash, crash, but clean up the memory first. And with this one, it's abort, and it's sort of like I aborted. And this is crash immediately. The memory is the OS problem. So if I comment that entire line out, now abort should be called. Why are you still? Cannot find the abort macro in the scope. Wait, I thought it was still a macro. By default, this means, oh, wait, so there's no, so it wasn't that there was an abort macro, it's just that in the cargo.toml, we want to say panic equals abort. So only works with panic with a change in toml file. So if we go to our cargo toml, then we can change, where does that go? So it's in a profile.release. Can I just say, what if I don't do that? Okay, so if I do, you still need the panic and just change the way the panic behaves. Ah, okay, I see. So this one here, it's not abort. This is still a panic. It's more of, okay, panic with this, crash but clean up the memory first, unless abort is set in the cargo.toml file. Then YOLO, the memory is now the OS's problem. All right, okay. Using a panic backtrace. Let's look at another example to see what it's like when a panic call comes from a library because of a bug in our code, instead from our code calling the macro directly. Listing 9.1 has some code that attempts to access an element by index in a vector. So it's accessing like the way wrong one. So I'm guessing that internal, they actually are using a macro. they're using a panic macro. So if I come here, multi-line this, let's not panic that. And so if we do this here, we can now cargo run. Okay, so finished running. Thread main panicked at index out of bounds. The length is 3, but the index is 99. Yeah, okay, so here. Checkout source libcore slice mod.rs line 865. So we need to run rust backtrace. So when we run cargo run, we also do like that. No, okay. Although this looks like a some kind of event, like a environment variable. I wonder if I could just do export west backtrace equals 1, and now just do a cargo run. Oh yeah, that's all I need to do. Okay, so unwind the backtrace. So that's using GCC. We have our print backtrace. So we want to go back and find our code. Panic format, panicking, slice index. Here it is, main RJS. So panic at main, so finally our code. And then going where's the 800? So where's the 865 line? Right here. That's where I guess the panic was like initially called by them, and then but then here's our line where it did that. All right, so that's pretty cool. Here we're trying to access the 100th element of our vector, which is at index 99, because indexing starts at 0, but it only has 3 elements. In this situation, Rust will panic. Using empty brackets is supposed to return an element, but if you pass an invalid index, there's no element that Rust could return. Here that would be correct. Other languages like C will attempt to give you exactly what you asked for in a situation, even though it isn't what you want. You'll get whatever is at the location in memory that would correspond to that element in a vector, even though the element doesn't belong to that vector. This is called a buffer overread and can lead to security vulnerabilities if an attacker is able to manipulate the index in such a way as to read data they shouldn't be allowed to that is stored after the array. To protect your program from this sort of vulnerability, if you need to read an element at index that doesn't exist, Rust will stop execution and refuse to continue. Let's try it and see. So we did that. The error points to a file we didn't write, vec.rs. That is the implementation of vec.t in a standard library. The code that gets run when we use the empty brackets in our vector, v, is in vec.rs, and that is where the panic is actually happening. The next note line tells us that we can set the Rust backtrace environment variable to get a backtrace of exactly what happened to cause the error. A backtrace is a list of all the functions that have been called to get to this point. Backtraces in Rust work as they do in other languages. The key to reading a backtrace is to start from the top and read until you see files you wrote. That's the spot where the problem originated. The lines above the lines mention in your file are code that your code called. I love like having to write like describing a backtrace. It's just there's so many repeating words in that. It's so dense. The lines below are code that called your code. These lines might include core Rust code, standard library code, or crates that you're using. Let's try to get a backtrace by setting the Rust backtrace environment variable to any value except 1. Listing 9.2 shows output similar to what you'll see. Do I get something vastly different if I set this to like 9? To start backtrace. The same number of steps. It's I'm not seeing anything like different by doing a different number. So I think it really is maybe just checking 0 and 1. I mean, that would make sense, right? Boolean. All right, what did we do? That's a lot of output. The exact output you see might be different depending upon your operating system and the Rust version. In order to get backtraces with this information, debug symbols must be enabled. Debug symbols are enabled by default when using cargo build or cargo run without the -- release flag, as we have here. In the output listing 9.2, line 11 of the backtrace points to the line in our project that's causing the problem. Line 4 of main RS. If we don't want our program to panic, the location provided by the first line mentioning a file we wrote is where we should start investigating. In listing 9.1, where we deliberately wrote code that would panic in order to demonstrate how to use backtraces, the way to fix the panic is to not request an element at index 99 from a vector that only contains 3 items. When your code panics in the future, you'll need to figure out what action the code is taking with what values to cause the panic and what the code should do instead. We'll come back to panic when we should and should not use panic to handle error conditions in the to panic or not to panic section later in this chapter. Next, we'll look at how to recover from an error using results. Okay, recoverable errors with result. Most errors aren't serious enough to require the program to stop entirely. Sometimes, when a function fails, it's for a reason that can easily interpret and respond to. For example, if you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. Recall from handling potential failure with the result type in Chapter 2 that the result enum is defined as having 2 variants, OK and error, as follows. Yeah, so I remember like we seen this. The T and E, so that's type, right, are generic type parameters. We'll discuss generics in more detail in Chapter 10. What you need to know right now is that T represents the type of the value that will be returned in a success case with the OK variant, and E represents the type of the error that will be returned in a failure case within the error variant. Because result has these generic type parameters, we can use the result type and the functions that the standard library has defined on it in many different situations where the successful value and the error value we want to return may differ. Let's call a function that returns a result value because the function could fail. In listing 9.3, we try to open a file. Okay, so use standard file. We attempt to open a file. Of course, it doesn't exist yet. So I think, well, this will panic for us, right? If we move in and we want to cd out of here, instead we're gonna cargo new, and this is gonna be the result type. Also, I want you to be closed. Okay, so opening this over here, you popping up, of course, main RS. If we use standard file system file, we then attempt to open hello.txt that doesn't exist here. And of course, we're not using it here, but if I run this, my guess is it's just going to panic right here, right? So cargo run. It would help if I also save the file. Wait, did that work? Okay, that's actually really interesting that that worked. You didn't like create. I didn't create a hello.txt anywhere. So I'm actually really curious about why that worked. All right, let's continue on. How do we know file open returns a result? We can look at the standard library API documentation, or we could ask the compiler. If we give a give an F-type annotation that we know is not the return type of the function, and then try to compile the code, the compiler will tell us that the types don't match. The error message will then tell us what the type of F is. Let's try it. We know that the return type of files open isn't of type u32, so let's change the F statement to this. So let F u32. Okay, so this is attempting to say like, hey, forcing it to be that way, which is why it's like, hey, you found this enum. I think for this one, it's this could be a match, essentially. Where in our match, we're then saying, okay, well, file enum, non-exhaustive patterns. This should be a, is it capital result? I think it is. And we're gonna do something with the result. And I think the result takes in something, right? We don't know what this is. It's like the type and the value. So is it the file? So like theoretically, we could then say that F equals files. And then of course we have the error panic, which would then, we'd want to call panic ourselves and say, oh no, this is where we potentially want to create the file, right? And say file create load.txt. All right, what are you yelling at? Match arms have incompatible types expected. Open close parentheses, found enum, standard result. Oh, right, because this is returning. This one's returning what it is, which this one we don't want to return. So if I wrap this in here, put a semicolon on the end, I don't think it will return anything anymore. Expected tuple struct variant found enum result. Did you mean to use one of the following variants? Standard result, error. Can I do this? Result, okay. Unused standard result, which must be used. Okay, so we can't just do a file create here. We'd have to like do another match or something else. Okay, that's actually really interesting to do. I wonder if how they're gonna really do it here. This tells us that the return type of the file open is a result. The generic parameter t has been filled in here with the type of the success value, which is a file handler. The type of e used in the error value is standard IO error. This return type means the call to file open might succeed and return a file handle that we can read from or write to. The function call might fail. For example, the file might not exist, or we might not have permission to access the file. The file open function needs to have a way to tell us whether it succeeded or failed, and at the same time give us either the file handle or error information. This information is exactly what the result enum conveys. In the case where file open succeeds, the value in the variable f will be an instance of OK that contains the file handle. In the case where it fails, the value in f will be an instance of error that contains more information about the kind of error that happened. We need to add to the code in listing 9.3 to take different actions depending on the value file open returns. Listing 9.4 shows one way to handle the result using a basic tool, the match expression that we showed in chapter 6. So yeah, that's what we sort of did, which was, okay, we attempt to open this, and then are matching on f instead of matching directly on file open. I guess it's because they're returning, like this match is returning this, so it's okay. If it's okay, we get the file and return the file. If it's an error, we get the error and we can choose to panic saying, hey, this is what that error is. Using a match expression to handle the result variance that might be returned. Note that, like the enum option, the result enum and its variance have been imported into Prelude, so we don't need to specify result before the OK and error variance in a match arms. Here we tell Rust that when the result is OK, return the inner file value out of the OK variant, and then assign that file handle value to the variable f. After the match, we can use the file handle for reading or writing. The other arm of the match handles the case where we get an error value from the file open. In this example, we've chosen to call the panic macro. If there's no file named hello.txt in our current directory, and we run this code, we'll see the following output from the panic macro. So yeah, if we change ours to work, what I'm actually thinking of is this kind of makes sense. We can say, okay, let file equals kind of want to do this. Let f equals, okay, we're gonna match and attempt to open this. Result, it's not result, it's just okay. Got that wrong. So we're gonna do error, and then this is the file handle, and then we're just going to return the file. The shadowing of f seems kind of strange, but I guess it works. I don't think I need to shadow it here. I think I can just go on and do this. Now we want, instead of underscore, we want the error. If there's an error, instead of doing something crazy like this, what I can do is maybe run a function, which is like create file, and name it, and like pass it hello.txt as the name. Of course, this is going to error because it's saying, hey, create file doesn't exist, and match bindings cannot shadow tuple variants. Is it error? Oh, we need to take in the error like that. I guess for right now we should probably just print that. So print line, and we really want to know there was an error, and debug print this error. Mainly because I'm curious about what the exact message is, because we could do like an if statement. Match arms have incompatible types. This is also interesting because it's left app equals f this. Oh yeah, so I see. They're using the arm like that. Oh, this is, oh, they're panicking to quit. So it's not print line. They're doing a full panic here, which of course won't ever return. So now Rust is happy with that. If we run this, We panic. There is an error in the OS code 2 kind not found message no such file or directory. Is code 2 associated with no such file or directory, or do I have to search for that error, like not found? I think maybe not found. And is this a structure? So can I do not found? Or not found? Oh, not found with capitalized. Is that a tuple? Is it this? Failed to resolve use of undeclared type or module error. So yeah, I'm not sure how to best extract what the error is, but maybe that's going to be in the future things. Because like if I want to get the message out of it, I want to say something like just dot, what dot, no field on it. So I think, oh, kind, it would be kind. Attempt to take value of method kind on type, standard error. Maybe a call to it is missing. So right now, I think we'll keep it as this. But I think what we'd want to do eventually is like check the kind, and then we can go and run a function that creates the file. All right, let's continue. Pull up the docs and file and see if it has any enums or anything for the file not found error. That's a good idea. Let's do Rust file. Okay, reference to an open file in a file system. And this is the same file we're using. Yeah, standard FS file. So we want the returned error. Well, it's a result, right? So it returns a result. Also, I find it interesting that they're all using the question mark for the result, handling the result. But what I really, okay, so it returns this result. If we come into here, result in this error. This still using type definitions. We have the prelude, which is results, structures, buff reader, buff writer, bytes chain, characters, error. Okay, go in here. Get mood, inner, kind, from debug, from display error, send and sync, models, the structures, that's just part of the same thing, the enums, error kind. A list specifying general categories of IO error. There's trait implementations. But can we find, that's where we got error kind. Is there anything in here that we can then use to say, okay, so not found, is the entity was not found often a file? It is not recommended to exhaustively match against it. It is used with the IO error type. Okay, so not found. Error kind is an enum that is inside. Okay. Then we have error kind. So an implementation of error kind on error. So as string. Oh, as string is interesting. Okay, which returns a reference to a string, which is, okay, that's the problem that we'd run into. So we could do that. For error. I think that's the. Okay, so if we take implement error kind as str. I guess they're just pulling the error the OS throws them. I think that's what they're doing. Either that or they've actually set this. They've like set this as a string literal. But if we do error kind here, matching against self as string, so we get this error. Can I do error dot as str and run that? It's a full function. If I say that, it says no method as string found for type centered error. Now if I do this running error kind, that work? Failed to resolve uses undeclared type module error. Use of undeclared type module error. Okay. So the error we're getting here is not exactly the same. In fact, this is the data structure, and the message is this. For a struct, can we do a get for it? And I realize it's 8:03. I'm gonna have to go pretty soon, so let's just try a get for message. If I do that, a get is no method get found in here. Okay, so it's not a structure. It's maybe it's its own type, maybe it's something else. I'm not going to worry about it right now. We'll continue on. So what I want to do is come up to our documentation, come up here. We are on chapter, on this link. Wait, can I just, okay. We're here. So if I save all of these things, sort of going through chapter 9. We'll send you up. You back here. And let's vim the readme. Okay, so currently we are done with this. Chapter 9, but in reality, we are here. So okay, so this sets up with, oh, I didn't want to. Foreground. Okay, and status -am updated where we are at, and get push. All right, so everything is pushed up. You can see the code changes. Thank you, Stacking. Thank you, Miguel, for stopping by and watching this morning. It's been a lot of fun, sort of like continuing learning through these. I would love to know what these error types are, and hopefully the book will go through a little bit more. And if it doesn't, maybe I will I don't know, maybe I'll find someone who knows a lot of Rust, and can ask them what's going on. And if I do find out, I will definitely be putting that into the wiki. And also, it sounds like that's just not as much, not something that is much as known. So I might create a video and talk about it as well. So again, I'm trying to do this every single weekday morning at 7 a.m. Mountain Time. Thank you for stopping by, and I will see you next time. If you enjoyed this, please follow the channel so that way you can get notifications when I go live. And with that, I'm out of here. Have a great rest of your day.